So start. So today we'll discuss sequence detector. Sequence detector. Okay. So sequence detector, which is also called milli machine. So it is one kind of machine or automata where you consider output with input, and we specifically detect some sequence. When our desired sequence is found, then the output is 1. So output is 1 means we got the sequence. But when the sequence is not there, then output is 0. So output 0 means the sequence is not achieved. So take an example. Say we want to design a sequence detector for the sequence 0101. That means when our sequence is 0101, then output is 1. Otherwise, output is 0. Next example. Say our sequence is 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, the sequence. Now, in which bit we will get output 1? Say, first of all, first we scan 0, then 1, then 0, then 1. So, when we complete this 0101, then the last 4 bits 0101, last 4 bits. So, when we scan this one, then we look at last 4 because our sequence is last 4 bit. So when, because our sequence is 0101, mind it. So when we get this last one, then we look at last 4 bit. Last 4 bits are 0101. That means we got our sequence. So when we get this one, then our output is 1. Otherwise, for the first 0, output is 0. For the first one, for the first one, output is 0. For the second 0, output is 0. Now proceed. When we get, sorry. So again, I 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 1. This. Say when we get this number, because first 4 bits already we have scanned, and output was 1 for that bit only. Now we scan this one. Now we scan this one. When you scan this one, also look at last 4 bit. Last 4 bit is 1011. Last 4 bit is 1011. When you scan this one, so 1011 is not our desired sequence. So for this one, output is 0. So next we scan this bit, this one. So for this one, for this one, again look at last 4 bit. Last 4 bit, it is 0111. Again, these last 4 bits are not also 0101. So for this last, this one also output is 0. Now look at this 0, this bit. Again look at last 4 bit. So last 4 bit is 1110. So it is 1110. So for this 0, when last 4 bit is 110, so it is not our sequence. So last, for this 0, output is 0. Now we scan this one. For this one also, last 4 bits are 1101, 1101. So output is 0. Okay. In this way, when we scan this one, this 0, when we scan this 0 for the last 4 bit, Last 4 bits are, when you scan this 0, last 4 bits are 1010, 1010. That means also the sequence is not achieved, because sequence is, remember, sequence is 0101. So also for this 0, we go, output is 0. Now we scan, next we scan this one, this one. For this one, again look at last 4 bit. Last 4 bit is 0101. Yes, we got the sequence. That means for this one, we produce output 1. Now, when we scan the last one, again look at last 4 bit. Last 4 bit for the last one, it is 1011. It is 1011. So not the sequence. That means for the last one, output will be 0. In this way, a sequence detector, it scan each bit, and for the sequence 0101, since it is 4-bit sequence, always it look at last 4 bit. When it scans a bit, it look at last 4 bit. So when the last 4 bits are 0101, then output is 1. Otherwise, output is 0. This is for this example. But if, say, if your sequence is 01010, then your sequence is 5 bits. In that case, when the detector detects or a bit, then it looks at last 5 bits. So how many bits it will look for, it depends on what are the number of bits are present in your sequence. So if that sequence is present for that bit, for the last 4 bits or last 5 bits, whatever, then output is 1. So now take how to design this sequence generator. So our bit is, remember, bit is 0101. These are bit. So first starts with initial state A. Remember our here our desired input, first desired input should be 0. So when we get a 0, this is our input 0, we go to next state, that is our B. And since when we get the first 0, since it is not our since we have not get the actual sequence still, so for this 0, the output should be 0. That's why the output, it is 0. So this pattern means first one is input and second one is output. Okay. So 0101, for the first 0, we go from A to B. And for the first 0, since the sequence is not detected, so for the first 0, output is also 0. Okay. Now uh, now for the second one, now look at this one, so that means when we are in state B, when input is 1, we go to next state C, because after 0 we need 1. So when first input is 0 and when next input is 1, we go to next state C. Okay. Okay. Now when you are constructing in this way, remember, for each state you have to mention for all the inputs. For each state you have to mention all the inputs. For example, uh, for state A, we have mentioned transition for 0, but we have not mentioned transition for 1. Since our sequence is 0101 and since our first input should be 1, so we have first made a transition from A to B for 0. But if first input is 1, what happens? Because we don't know what will be our sequence. It may happen that the first bit starts with 1. Then we will nothing to do for the initial state. Then we have made a self loop, that is a loop back self path, self loop for 1. Why for 1 self loop? Because initially 1 is not desired, we desired 0. So initially when the first input is 1, we simply wait over a until we get a 0. That's why for 1 we have made a loop for a. And since for first input 1 it is not the sequence, so obviously output is 0. Similar, okay? So now 0 1 0 1 the sequence. Now similarly look at for b part. Look at for b. When we are in b, that means we already got a 0. So when we are in b, we have made a transition for 1 from b to c. Why? Because 1 is our desired input. Now what happens if when we are over b, input is 0? That means this sequence, first input is 0 and second input in place of 1 also it is 0. What happens? Also in this case, we need 1, right? We need 1, we don't need 0. It is not desired, we need 1 in place of this 0. So we simply make a loop over b for 0, since we need 1. And also since this 0 is not desired, also output, corresponding output is also 0. And one question, why we are over b for this 0? Why we have made a self loop over b for this 0? Because after this 0 we need a 1. In place of this 0 we need a 1. Since 1 is producing from b, 1 is producing from b, so we simply stay over b. Because after this 0, when a 1 will appear, then we may proceed further, because we need a 1 and 1 is emitting from b. So for the second 0, for this second 0 we stay over b. Okay, so now so the 0 1 0 1, now we are over c. Over c means already we have scanned 0, we have scanned 1, that is already you have got 0 and 1, these 2 bits. And we are over c, that is now we are over c. Now what happens if 0 is input or 1 is input? Let's check one by one. So now we are over c. Now say input is 0. Of course if input is 0, that means it is our desired sequence. So we will simply move to the next state, d, for this input. And since still we have not got the sequence, still it is 0 1 0, not it is 0 1 0 1. So since still we have not got the sequence, so for this 0 output will be 0. Fine. But what happened if you got this sequence? First one is 0, second one is 1, third one in place of this 0 also we got a 1. That means when we are over c and in place of 0 we got a input 1, this 1, what happens? Acha, look at the sequence. When we are over c, listen carefully, when we are over c and we got a sequence 0 1 1 still now, that means our sequence is completely destroyed. Why completely destroyed? Because from this sequence, if we want to start or get back our sequence, we have to start from 0 1 0 1. Am I right? Just you can think, when again I repeat this thing, when we are over c and if your input is 1 in c, then our sequence we got till now up to c, it is 0 it is 0 1 1, but our desired input should be 0 1 0 1. This is, that is when we are over C and we got a 1 and then we got a sequence 0 1 1. But in this case, to get back our sequence, okay, our sequence should be then again 0 1 0. That is, we have to again get a 0. We again have to get a 0 to start the sequence again. Because when this input is 1 over C, then our sequence completely destroyed. To get back the sequence, we have to start with again 0. And 0 is emitting from A. Look at, 0 is emitting from A. That's why when we are over C and input is 1, we go back to A. Why? Because if we go back to A, then we can get a 0 and we can get a 1 from B. That is, this sequence again can repeat, can start. Have you got this point, all of you? Why for C, we have not made the loop. We have go back to A. For capital A, for capital A, for 1, we make a loop. For capital B, for 0, we made a loop. That is, which are undesirable bits. But for C, when 1 is undesirable bit, we don't make it at loop. We go back to capital A. This is for, again I repeat, when we are over C, we got the sequence 0 1 1. But 0 1 1 is not our sequence. Now your sequence completely destroyed. To get back the sequence, again we have to start with 0 and then again 1, then again 0, in this way. That's why again you have to start the sequence. And this 0 is can be started from initial state. That is, you have to again start with the initial state. That's why for this 1 over C, we go back to capital A. But capital A, again start the sequence. Okay. Now, so our sequence is 0 1 0 1. So now say we are over D. Over D means which bits already we have scanned. We have scanned 0. We have scanned 1. We have scanned 0. For the first 0, we simply come from A to B. For the second one, we come from B to C. For the third 0, we come from C to D. So when we are over D, that means we are now going to scan the next bit, that may be either 0 or maybe on 1. So let's start, say, first, if our input is 1. So if our next input is 1. So when we are over D, listen carefully, when we are over D and our next input is 1. Now look at the sequence. We got the sequence 0 1 0 1. So when we are over D and input is 1, then our sequence simply completes. Okay. So first of all, so remember, that means for this case, output for this bit, output should be 1. Number 1. Number 2, which should be the next state? Should we draw next state as capital E? No. Your diagram should be optimized. You may draw a next state as, you may draw for capital, for 1, you may go to capital E. No. Your diagram should be optimized. Why? Because after this one, again you will, again this will be a scenario that again this one, that this will scenario that you will get a 0, you may get a 1, you may get a 0, you may get a 1. That is, your sequence again repeat, right? So sequence return means the sequence can repeat. That's why you should try to make a loop back or feed forward path. So from D, the feed forward path may be to C, maybe to B, maybe to A. Why? Because your sequence may repeat. Now the question is, which state we should go back to? Which state? Either to C or to A, B or to A. To which state we should go back? For that case, we have to simply look at forward scenario. Okay, so let's say this is our 0 1 0, this is our sequence. So we are over D. That means now, say now we are going to scan this one. Now just think in advance. After this one, what is the minimum bit by which we can again get back the sequence? After this one, if we again get 0 1, look at carefully. After this one, if we again get 0 1, then look at the sequence. The sequence again repeat 0 1 0 1. So after the last one, your sequence may repeat if we get a 0 and 1 again. Why? Because in that case, last 4 bits become again 0 1 0 1. So we have to think intelligently. So after this one, when we are over D, then we should go back to the state from where 0 is emitting, or from where we can get 0 1, right? So when we are over D and input is 1, then we should go back to the state from where we can get back a 0 and 1, such that your sequence will repeat. Now look at in which state, if we go to A or C, in A also 0 is emitting, and from C also 0 is emitting. So for the last input one in D, we may go back to either C or we may go back to either A, because for the last bit 1 over D, our next bit should be 0. So looking at the future, so we may go back to C because from C 0 is emitting, or we may go back to A because from A 0 is emitting, because our next bit should be 0. Now question is, to which state we should go, whether we should go to A, we should go to C. Anybody, can you suggest which state should be better, whether go to A or go to C when we are over D and input is 0? Sorry, input is 1 for the next case. Look at the diagram. If we look at the diagram, 0 1 0 1, we are scanning 1. Listen carefully, we are scanning 1, we are over D. Now if input is 1, fine. If we go back to C for this one, and since for this one we get back the sequence, output should be 1. So for when we going back to C from D, output is 1. The output is 1 because you get back the sequence. Now if we go back to sequence, what is the advantage? Look at, from C, if your next input is 0, blue means next input, and blue means now you are in C. If your next input is 0, you can again go back to D for this 0. And after this 0, if your next bit is again 1, then from D again you can go back to C. And look at, when you are getting this 0 1, then again your sequence repeat 0 1 0 1. That means if we put 0 1 0 1 0 1 in this way, then your sequence always repeats. That is, for the last bit 1, in this case, if we go back to C, then for 0 1 0 1 0 1, it creates a loop which simply repeats the sequence. But if you go back to A, it will not repeat the sequence. It will repeat the sequence, but from the initial state, from 0, 1, 0, 1. But simply we need 0, 1 to get back the sequence. That's why go back to C. But if say if 1D for 1, if we need 0, 1, 0, 1 to get back the sequence, then we go back to A. But since in this case we need simply 0, 1 to get back the sequence, we go back to C, not to A. But remember one thing, to repeat the sequence in the last state, here D is the last state, to repeat the sequence in the last state, if we need to get back the sequence from the initial, or if we get back the whole sequence from the initial state, then we go back to initial state. Otherwise, if partial bits can repeat the sequence, we back to an intermediate state. In this case, only 0, 1, only partial bit 0, 1 is enough to repeat the state, to repeat the sequence. That's why for D, for 0, 1 or for 0, for 1 bit, we are going to C, not to A. Okay. So now, okay, fine. Now, so 0, 1, 0, 1, we have scanned the last one. Now we are over D. We are going back to C. It is fine, and output is 1 because because we get back the sequence. Now what happens? This scenario, if input is 0, 1, 0, 0, that means when we are over D, your bit is 0, not 1. Last case, what to do? Again, just look at advance. How many bits, minimum number of how many bits is required in this case to get back the sequence? So when we are over D and input is 0, not 1, then I think if we get a 1, 0 and 1, then it will again repeat the sequence. Look at, when we are over D and input is 0, then after that, if we get a 1, 0, 1, then sequence repeats 0, 1, 0, 1. Right? That means for this 0, we should go back to a state from where we can get 1, 0, 1. Right? From where we can get 1, 0, 1. Now look at 1, 0, 1 can be obtained from state B, because 1, 0, 1. Look at 1, 0, 1. Since 1, 0, 1 can be obtained from state B, so from D, for 0 input, we are going back to B. And since if we get 0 in place of 1, it is not the sequence, so output is obviously 0. Okay. So this is the overall construction. So again, I repeat the overall scenario once again. Our input is 0, 1, 0, 1. So always move forward when your input is input is desired input. So first input should be 0. So for state A, for input 0, go back to B. So first input is 0, it is not our sequence, so output is 0. But if first bit is 1, then it is a not desirable input. First input should be 0. So we simply go back to A by self loop with input 1 and output 0. Okay. Now next input is 1. Next input is 1. From B, we go back to C for input 1. Since it is not the sequence, output is 0. But what happens if it is 0? If it is 0, then again we need simply 1, right? And 1 is producing from B. That's why we simply for 0, we simply go back to B by self loop, and since it is not the sequence, output is 0. Now next input is 0. So next input is 0. From C we go back to D. So we got still now 0 1 0. But since it is not the sequence, output is 0. But what happens if we got this sequence 0 1 1, that is in place of 0 in C we got 1. So look at, if we got a 1 in C, our sequence completely destroyed, because from this one to get back the sequence we have to again start from 0 1 0 1. That's why for C, when input is 1 we go back to initial state A, because we have to start again from the initial 0 1 0 1, and output is 0. Obviously sequence is not obtained. Now last one, say our last input is 1. That means yes, 0 1 0 1 sequence completed. When you are scanning the last input, you just look at advance. After that, if you get a 0 and 1, then our sequence will repeat. Why? Because look at 0 1 0 1 sequence repeat. That's why when input is 1 and we are over D, we go back to C, because from C again we get a 0 and 1, and this section 0 1 creates a loop which we need 0 1 0 1. Okay, that's why for the last input 1 we go back to C, because after that if we get 0 1 sequence repeats. That's why we go back to C. And since for this one in output your sequence is achieved, so for this one your output should be 1 when you're going back to from D to C. Fine. But what happens if your input is 0 not 1 over D? That is you got this one 0 this one 0 1 0 0. That is we are getting you are getting 0 in place of 1 over D. So just look at, we need, after that we need simply 1 0 1. Why? Because if you get 1 0 1 after that, then your sequence repeat 1 0 1 0 1. So we need 1 when we are over D and input is 0, we need 1 to get back the sequence, and 1 is emitting from B. That's why for this 0 for this 0 over D, we are going back to B, because from B if you go to B, then 1 0 1, this one can be obtained. If this one can be obtained, then 0 1 0 1 can be obtained. Okay, so this is our overall diagram, what is called sequence detector or Mealy machine. Okay, now after that we have to design the table. So look at the table. This is our table. This is called state table. So state table. The state table, write the present state A B C D, next state, and Z is output. Next state is an x is input 0 and 1. For present state A, for input 0, next state is B. Simply convert the diagram into table. What is corresponding output? Output is 0. So output is 0. So comma part is output. So for present state A, if input is 1, we simply go back to 1, to go back to A. So next state is A. What is the output? Output is 0. So after slash, remember after slash this part is output. Okay. Next, when we are over B, input is 0, next state is also B. Output is 0. And if input is 1 over B, we go to next state C. So next state C. Output is 0. In this way, just fill up the table. And lastly, one thing for D. For D, When input is 0, next state is B, output is 0, and when input is 1, next state is C. Only in this case, output should be 1, because only in this case we are getting the sequence. We are simply getting back the sequence. Okay, so I think time is to be ended. Acha, I will upload this last class video, last class material I have not uploaded. I will upload it by tomorrow, by today, and also I will upload it this one by today. All of you are requested to simply please do it. 1 1 1 1. Simply do it 1 1 1 1 and design a sequence detector to detect the sequence 1 1 1. That means when input is 1 1 1 1, output should be 1. The solution is given. Solution is given. Just you can go through the solution, but first of all, I suggest you simply you go through it, understand it, and you try to make it 1 1 1 1 yourself.
ठीक है sir.
Then look at the solution. Okay.
Okay sir.
Okay. So our time is going to be ended. Okay. So by today I will upload this the last class, also this video, this material. Please you go through it, and one example, try to do it 1101. All of you try
Okay
a detector 1101. So your homework is 1101 and 111. Okay.
okay sir.
Oh, so do it. So if you have any query, so tell me. I think time is going to be ended, so you will discuss it in your next class, or you may give a query in your WhatsApp. Okay.
Okay sir.
Okay. So but practice it. Go through it,
ठीक है sir.
and practice it bit by bit. Actually, when we practice it in this way, 0 1 0 1, bit by bit, as I have discussed you, bit by bit. First check 0, then 1, then 0, then 1, bit by bit. Okay. So okay, thank you. Any
ठीक है sir.
query?
Thank you sir. No sir.
Okay. So please go through it and please try it. Okay. Thank you all of you.
Thank you sir.
Thank you.